Hi there. In this video, I'll be talking about how we can use completing the square to take a quadratic and put it in vertex form. Our standard form, y equals ax squared plus bx plus c, looks very nice, but it's not the best for understanding what a graph looks like. For a graph, it's nice if we can think about the shifts. So here's the basic idea. If we have some quadratic in the form ax squared plus bx plus c, the first thing we're going to do is look just at these first two terms, the x squared term and the x squared, and we'll factor out the leading coefficient from both of them. So that would look something like so. The third thing, the c, just leave that as is. And you can see if I distribute it, I have ax squared, and then a times b over a would be bx. Now we would look at this part here, has an x squared all by itself, has something with an x, we complete the square there. So we figure out whatever the appropriate number is to complete the square. And then within the parentheses, so here within these parentheses, we add that number and then subtract it immediately. So we haven't actually changed the value, but we've created that perfect square. If we have done this correctly, then these first three terms inside the parentheses would give us a perfect square. So we rewrite that as whatever square it is. All of this is still inside these parentheses. The a is multiplying all of that. So there's a constant that's been on the outside all along. Inside we have a perfect square minus some other constant. Then finally we'll distribute the a and simplify. So let's take a look at an example. If I had y equals 3x squared plus 12x plus 10, the first thing I would do is take the 3 and factor it out of those first two terms. Leave the plus 10 as it is. Now, inside those parentheses, I would figure out how to complete the square. Half of 4 is 2, 2 squared is 4. So I would add 4 to complete the square, and then immediately subtract 4 to cancel it out. So I haven't actually changed the value, I've just changed the appearance. This thing right here is a perfect square. So I have y equals 3 times quantity x plus 2 squared minus 4 plus 10 out here. I could distribute that 3 to have 3 times quantity x plus 2 squared minus 12 plus 10. 12 is from 3 times 4. And then I would notice that the negative 12 plus 10 can be written as negative 2. So this is my answer in vertex form. And if I look at it this way, I would know exactly how to graph it. It's like x squared, but 3 times as tall. It's been shifted 2 units to the left and 2 units down. So I would know, for example, that the vertex is at negative 2, negative 2. Here's another one for you to try. If you're not 100% sure, look at the steps. And I'd recommend hitting pause on this video to do it. So I hope you've tried. We factor out the 2 just from the first two terms. You might have a hint here when you notice that the third term's not divisible by 2. Even if it were, leave it by itself. Within the parentheses, we want to complete the square. So that would involve adding 16, half of 8 is 4, 4 squared is 16, and then immediately subtracting it. So inside these parentheses, we have x plus 4 squared minus 16. I can distribute the 2, so I have 2 times quantity x plus 4 squared minus 32 plus 17. If I combine those constants, I get negative 17. This would be a parabola that's twice as tall as our standard parabola, shifted 4 units to the left and 17 units down, so the vertex would be at negative 4, negative 17. So hopefully that makes sense to you. You can practice this by making up your own and just checking by graphing if the vertex is where you think it should be.